Why is a potentiometer called a potentiometer? Does it measure anything? Isn't it simply an adjustable resistor? Is it more accurate than a voltmeter? Those and other questions that you even haven't thought of asking about potentiometers in today's video. Enjoy! The E-series are very important from the manufacturer's point of view. Overall standardization is one of the best things in this world. For once, everyone agrees upon something. Those series of predefined values are made only for fixed resistors. And fixed is not necessarily good. It is not very convenient to change a resistor every time you need to tune your system. And that's where a potentiometer or a variable resistor comes into play. You can find them in audio equipment like electric guitar or inside measurement tools for fine adjustments or calibration. But it's not its main use, we will get to it in a minute. The potentiometer has 3 contacts, 2 external terminals that are connected to the resistive track, whereas the middle is connected to the wiper. As you slide or rotate it across the resistive track, the resistance between terminals 1 and 2 and 2 and 3 is changing. In electronic schematics, the potentiometer is represented as a regular resistor with 2 terminals and an additional terminal with an arrow pointing into the center of the resistor. We can simplify it by dividing the potentiometer into 2 fixed resistors, R1 and R2. And as you observe, we got ourselves a variable voltage divider with which we can control the output voltage on RL. If you go to TME's website and search for potentiometers, you'll have 4 categories to choose from. Those are trimmers, shafts, sliders, and audio potentiometers. As I have already mentioned, the trimmers are designed for setting and forgetting, for fine-tuning of 1 or 2 touches to adjust the sensitivity of the sensor, not more than that. The shafts and the audio potentiometers, on the other hand, have higher IP rating, they are bulky and robust, and are designed for thousands of cycles, like the connectors from Harting. But that's another story. If you go to the PDF, Chinese, ni hao! Make sure that all the parameters suit your application, such as power ratings, dimension, resolution, characteristic, and if you go to the bottom of the page, you can see that the potentiometer is made for at least 10,000 rotations. Regarding the characteristics of the potentiometer, there are 2 options, either linear or logarithmic. As you can see from the graph, the linear curve gives us a 1-to-1 response. As we move the wiper, the resistance changes at a constant rate. A potentiometer with a logarithmic characteristics follow approximately a logarithmic curve, which is the best way to control volume because this is how our ears respond to loudness, and here we have also more control at the center. Here we have a multimeter, the Bryman BM257 is one of my favorites, but if you want a different multimeter you can go to TME catalog and pick one for yourself. To measure voltage we need to connect the probes in parallel to the component like in the schematic. To make sure the measurement is as accurate as possible, there should be any current flow to the multimeter from the circuit. However, in reality, even if there is a resistor in series which is a couple of magnitudes larger than R2, some current passes through. This can be very crucial for sensitive devices. So what do? Well, we use a potentiometer. Unlike voltmeters, a potentiometer doesn't draw any current from the circuit while it's measuring voltage. Considering the following electric circuit, we have a known source of high voltage connected in parallel to a potentiometer with a linear characteristics. And, on the other hand, we have an unknown voltage with a galvanometer. Let's recall that there is no current flow if you connect 2 sources with the same voltage. Similar to when you are charging a capacitor, the current stops flowing when the capacitor is full. We can adjust the output voltage between the first and the middle terminals by moving the wiper. To find the voltage across the unknown voltage source E, we need to balance the 2 sources using the wiper until the galvanometer shows no current flow. Knowing the output voltage per unit length of the potentiometer or the wire, we can calculate the unknown voltage by multiplying the constant and the length x. Wow, I must say that there is much more info about those potentiometers, like why do we have a digital one, or why these have 6 terminals. But this is for future videos. If you like this video, make sure to check others on our channel, and if you want to know more about those potentiometers, make sure to check the link in the description.